In 1977, the Voyager 1 space probe was launched to study the outer solar system. The two Voyager space probes have become the longest operating spacecrafts in spaceflight history. 41 years later, Voyager 1 is now 21 billion kilometers from Earth and traveling at 61,000 kilometers per hour. Despite Voyager 1 being the farthest man-made object from Earth, we are still able to communicate with the space probe on a regular basis. But how far can it go before we can no longer communicate with it? To answer this, we need to know how Voyager 1 receives and transmits data from 21 billion kilometers away. A 20 kilowatt signal is transmitted from Earth to Voyager 1 using radio waves. It takes almost 20 hours for the signal to reach the space probe, where its sensitive antenna picks up the signal. For comparison, it takes the rovers on Mars an average of just 15 minutes to send messages back to Earth. Voyager starts sending data back to Earth using a 20-watt signal. As it travels through space, the signal strength weakens, and by the time it reaches Earth, the signal is barely detectable. In order to communicate with objects that are this far away, it doesn't really matter how strong the signal is, as long as you have a receiver that is sensitive enough to pick it up. NASA uses the Deep Space Network, which consists of 3 antenna complexes equally spaced around the Earth. Each complex has a huge 70-meter antenna, along with multiple 34-meter antennae, which can be combined to pick up signals that are thousands of times weaker than your standard FM radio signal. The Deep Space Network spends several hours each day listening to faint signals from Voyager 1, and so far, it continues to talk back to us. Since our methods of detecting signals has improved drastically over the past 50 years, there isn't really a limit on how far we can communicate with objects in space. With our current technology, we could reliably communicate with objects that are many light years away from us, as long as our receivers are sensitive and accurate enough to pick up the extremely weak signals. As Voyager travels farther and farther away from Earth, it takes longer to send and receive signals. The signal strength also gets weaker, and data rates become slower, making it harder and harder to communicate with the spacecraft. Voyager 1 will continue on its journey indefinitely, and although there is technically no limit to how far we can communicate, our communication with Voyager 1 only has a few years left. Since Voyager 1 is nuclear-powered, the electrical power weakens each day. In 1990, in order to save power, engineers turned off the spacecraft's camera after Voyager 1 took the famous pale blue dot image, which showed Earth as a tiny blue pixel against the darkness of space. Today, only 4 out of the 11 scientific instruments on Voyager 1 are still active. These instruments are being used to collect data on magnetic fields, solar winds, and cosmic rays outside our solar system. In around 8 years, Voyager 1 will completely run out of power and will no longer be able to keep its instruments going. Scientists will continue to communicate with the space probe and receive the important information it gathers until it eventually sends its last bit of data and disappears silently into space, never to be heard from ever again. So although the end is near for the Voyager space probes, we can appreciate the incredible journey they have been on and the valuable science they have taught us.